All right, let's get right into it. Today we're diving into a really cool cosmic detective story. The main character? An interstellar visitor, Comet 3I/Atlas. And get this, two of our biggest space missions, the Hubble telescope and the JUICE spacecraft, have sent back some wild observations. They've basically handed us a puzzle that is just begging to be solved.
So our story really kicks off in late 2025. You've got the legendary Hubble Space Telescope, right? It turns its powerful eye towards this comet as it's cruising through our solar system. And what it sees is, well, it's not what anybody was expecting. This is our first big clue.
And here's the thing that makes you go, wait, what? A comet's tail pointing towards the sun? We all learn in school that the tail points away from the sun, pushed by solar wind. But Hubble saw something that seemed to defy that basic rule. So what in the cosmos is going on here?
Okay, so let's start with the evidence from Hubble. This is the clue that really made everyone scratch their heads and rethink what a comet should look like.
The picture that Hubble sent back, it wasn't that classic, sharp, streaming tail. No, it was this soft, glowing teardrop. A bright blob of light that was clearly reaching towards the sun, not away from it. Super weird.
Now, okay, this kind of thing does have a name. It's called a sunward anti-tail. It can happen when our viewing angle is just right. We're looking at the comet's trail of dust edge on. It's almost like an optical illusion. But the thing with 3I/Atlas was, this one was huge and incredibly clear, way more than just a typical anti-tail.
And this is the number that really made astronomers sit up and pay attention. This feature stretched for a mind-boggling 60,000 kilometers. That is not just some tiny little detail, it's a massive structure. And it turns out that very specific number is the key to this whole mystery.
Okay, now here's where a strange observation gets, well, it gets even stranger. That 60,000 kilometer number wasn't just pulled out of thin air. It was an almost perfect match to a scientific prediction that had already been made.
So get this. In a recent paper, a physicist named Avi Loeb had already done the math. He calculated that if this comet shed some big, solid chunks, those chunks wouldn't get pushed around by the same forces as the comet itself. And he predicted that by late November, they would have drifted about, you guessed it, 60,000 kilometers ahead of the comet.
I mean, look at that. You've got a theoretical calculation on one side and a brand new real-world observation from Hubble on the other. And they match, almost perfectly. That kind of coincidence just doesn't happen. It demands an explanation.
The physics behind this is actually pretty cool. So, imagine the main comet is like a little spaceship with its own gas jets pushing it slightly. Now, if some solid, rocky bits break off, they don't have those jets. They're just coasting. So they feel less of that push, and over time, they drift ahead of the main body, creating that sunward feature. It's all just natural physics at play.
But Hubble wasn't the only one watching. The plot thickens because, around the same time, the European Space Agency's JUICE spacecraft was also taking a look, and it saw something totally different, adding another fascinating layer to this mystery.
Yeah, so just a few weeks before Hubble's observation, JUICE took a picture showing not one tail, but two. And they weren't messy or fuzzy, they were distinct, narrow tails, almost like laser beams, pointing in different directions. That is definitely not your typical comet look.
So what could cause all this activity? Well, we already knew that 3I/Atlas was spewing out a ton of carbon dioxide, way more than the comets from around here. All that gas can create really complex jets and weird pressure patterns. You combine that with interstellar dust that we're not familiar with, and yeah, you could totally end up with some strange-looking tails. It's a big clue that comets from other star systems might be built differently.
Okay, so now we have two sets of clues from two incredible telescopes. Hubble sees a teardrop, JUICE sees two tails. It's time to put all the pieces together and see the bigger picture.
So let's connect the dots. Hubble gave us the super detailed close-up. It revealed the fine structure of the dust and that amazing 60,000 kilometer debris cloud. Meanwhile, JUICE gave us the wide-angle view, showing how all the gas activity was shaping two whole separate tails. You see? They're not contradictory, they're just two complementary pieces of the very same puzzle.
So when you put it all together, a completely natural explanation starts to form. We've got a swarm of rocky bits that broke off the comet, probably because of intense heat. These fragments then drifted ahead because they weren't being pushed by the comet's own CO2 jets. And the whole show is being shaped by sunlight and driven by the unique chemistry of an object that was born around another star. And that's really the main takeaway here. The teardrop, the sunward tail, the double tails, it all works within the laws of physics. It's just that this comet, being a guest from another star system, plays by a slightly different set of rules. Its chemistry, its structure, it's just not what we're used to. But you know what? This story is far from over. These first observations are just the appetizer. Scientists are on the edge of their seats, waiting for the next batch of data to come in. And we won't have to wait long. In February 2026, JUICE is scheduled to send down its full data package. We're talking high-res images, chemical fingerprints, the whole shebang. That's when we'll get our best look yet. And by March, the comet will already be crossing Jupiter's orbit, which is just a wild reminder of how fast these interstellar travelers are moving.
And all of this leaves us with one final, incredible thought. 3I Atlas has shown us that comets from other stars can be surprisingly weird, all while following the science we know. It just makes you wonder, what other secrets are these visitors carrying with them as they journey across the galaxy?